All right, welcome back. This is 2.5, part 1, take 3, due to technical difficulties on my end. Okay, so I am breaking up 2.5 into 3 short videos. So this first part, part 1, will cover what exactly is a function and how can you tell if something is a function. Okay, so take notes. All right, 2.5. It was on the eraser because I was lecturing thinking it was recorded. And then I had to erase everything. Okay, so 2.5, Intro to Functions. All right, so let's start off with this fancy definition of what a function is. So a function is a set of ordered pairs. So it's an ordered pair, so it has a first component and a second component. Also known as a relation, in which to each first component there corresponds exactly one second component. Okay, so the set of first components is called the domain of the function. Okay, and the set of second components is called the range of the function. All right, so I am going to draw you a visual. So if you are a little confused about what this is all saying, here are some visuals to help you understand. Okay. So suppose that we have this set of x values. We'll call them x1, x2, x3. But let's make that look like a 3. All right, so we have this set, right? So these guys are the first components. So these guys make up the domain. Okay, and so we have a function, call it f, and it maps these x values over here to these guys in some way. So this set over here is called the range. Okay, and so maybe the x value, x1, gets mapped to y1, and maybe x2 gets mapped to y3, and x3 gets mapped to y2. Okay, so here, this would represent what's called a function. Okay, so that's what it's saying here. Let's go back to the definition up here. So it's a set of ordered pairs in which to each first component there corresponds exactly one second component. Okay, that's going to play an important part right here. Exactly 1 second component. Okay, let's go back. All right, so that's what's happening here in this visual. So we have all of these first components get mapped to exactly one y value over here. Okay, so let me give you an example of what a function is not. Okay, so suppose that I have these x values here, right? And suppose that I have these y values over here. Okay, so I have these two sets. Okay, and suppose that x1 gets mapped over here. And suppose that x2 gets mapped over here and over here. And suppose that x3 gets mapped up to y1. Okay, so over here, this is not a function. And the reason why is because if you see here, x2, we see that x2 gets mapped to two different y values. And remember, up here, exactly 1. Okay, so there corresponds exactly 1 second component. Okay, so x2 doesn't have exactly 1 component over here. It's getting mapped to 2. Okay, so not a function because x2 does not map to exactly 1. Okay, 1 y value. Let me show you another one. Okay, suppose that I have these x values here. Okay, and suppose that I have these here. Okay, and suppose that x1 gets mapped to y2. So far, so good. So, and suppose that x2 also maps to y2. That's actually perfectly fine as well. Okay, so far, so good. They can go to the same y value. That's fine. Okay, however, suppose we just stop right here. If we stop right here, this is not a function. And the reason why is because x3 didn't get mapped to anything. Okay, so again, up here, it says each first component corresponds to exactly 1 second component. So each first component. Well, when I look here, each of these doesn't get mapped to a y value. Okay, so over here, this is not a function because x3 does not map to any y value. Okay, so make sure you understand what the reason is over here. Okay, so again, they can go to the same y value. That's okay. All right, very good. So let's take a look at these and let's see if we can determine if the relation is a function. Okay. All right. So let's take a look at this first example. All right. Suppose that my x's are made up of 5, 7, 11. Okay. And suppose my y values are made up of 4, 6, and 10. Okay. And suppose that 5 maps to 4, 7 maps to 6, 11 maps to 10. So tell me, do you guys think this represents a function or not? Good. Hopefully you said yes. Okay. Yes, a function. All right. Now it looks like I'm cursing. Okay. Yes, a function. Why isn't this working correctly? All right. Let's see what it comes up with. There we go. All right. Let's take a look at example number 2. All right. Suppose that I have a table of values. Okay. And suppose I have 8, 2, 1, 4, 8, 3, 9, 9. Okay. So here, hopefully you can see that this, remember, all the x values can go to exactly one y value. And we see here that 8 went to 2 values. 8 went to 2, and 8 also went to 3. Okay, so here, this is no. So not a function. Okay, so 8 maps to 2 values. 2 and 3. Okay. And let's take a look at this one over here. Okay, so again, the x's, they can only go to one y value. All right, so example number 3. Suppose that it's written like this, -2, 3. I have that point, -1, 3, 0, 3, and 1, 3. Okay, suppose that I have these points. Does this represent a function? Okay, so here's my x value, -2. Here's my x value, -1. Here's my x value, 0. And here's my x value, 1. Okay, all of those x values that I just mentioned, they all go to only one y value. Okay, so this is a yes. Okay, it doesn't matter that they all went to the same y value. They just have to go to a y value. Okay, and exactly 1. All right, let's have a look at this one. Suppose that I have this number and this number here. And suppose that I have these numbers for y, 2, 3, and 4. Okay, 2, 3, and 4. And suppose that I have this mapping. So suppose 0 goes there, 0 goes there, and 9 goes here. Okay, so here, does this represent a function? Okay, hopefully you said no. So not a function. Okay, not a function. Okay, and the reason why is because 0, right? 0 maps to 2 values. Okay. Very good. And let's take a look at this one over here. So what about this one? 4, -1, 9, 2, 16, 15, 4, 4. Okay, so is this a function? We have this x value, 4, this x value, 9, this x value, 16, and this x value, 4. Okay, so is this a function? And try to figure out, if no, why not? Okay, so you should have said not a function. And the reason why is because this x value, 4, gets mapped to -1 and +4. Make sure, because they might try to trick you, and they might put not 4, 4 here on the end, but they might say 4, -1. Okay, which is exactly the same point as this one over here. So make sure that 4 is really getting mapped to 2 different y values. Okay, if they do that, they're trying to trick you. I know, it's cruel. Okay, we had 4 here, right? Okay, so this is not a function because the x value 4, this x value 4 gets mapped here to -1, and it also gets mapped to 4. 2 values, -1 and 4. Okay. All right. So let's take a look at some graphs, and let's see if we can figure out if they are representative of a function. Okay. So we were able to look at these sets, a table of points, a set of points, these sets, points, and determine whether or not they are functions. So let's take a look at these graphically. Okay, so graphically. So a graph represents a function if it passes the vertical line test. I.e., if a vertical line placed anywhere would cross the graph no more than one time. Okay, so that's the requirement graphically. So you can use the vertical line test. Okay, the vertical line test is sort of a test that simplifies the definition of a function where every x value, it makes sense, right? If you have an x value, picture an x value on a graph on an xy plane. Okay, did you pick that x value? Picture it in your head. And now picture it going to a y value. So like you're plotting a point. Okay, so take that x value and plot it up against some y value, right? Now, if it goes to 2, right? If that x value gets mapped to 2 y values, right? Now you have a dot somewhere on top, and then you have another dot somewhere down below. And now the vertical line test, if you draw a vertical line, it would cross through those 2 points. Okay? All right, so let's take a look. Let's take a look at what I'm talking about. And then we'll end here. Okay, so for example, let's take a look at this one, A. Okay, so if I have this line, this graph of a line, right? If I draw a vertical line anywhere, right, then it would pass through this graph once. Okay, so this is a yes. Okay, draw a vertical line anywhere, and it crosses this line once. Okay, if we take a look at this graph, let's draw a parabola. Okay, again, if I draw a vertical line through this graph anywhere you draw that vertical line, it will only cross this parabola once. Okay, so remember, vertical line is like this, vertical. Okay. All right, what about this? Okay, suppose that I have this sideways parabola. Okay, well, if I draw a vertical line anywhere, so if I just choose to draw it here, well, guess what? It crosses through the graph at 2 points, 1, 2. Okay, so it fails the vertical line test. Vertical line test says, like over here in B, it can only cross the graph once. Okay, because what this is saying is that this x value right over here, this x value is getting mapped. This x value right over here is getting mapped to 2 y values, this y value and this y value. Okay, and remember, for this to be a function, each x value can only get mapped to 1. Okay, 1 y value. Okay, so this one is a no. Okay, and then the last one. If we have this, okay, so again, if you draw a vertical line anywhere, it only crosses at 1 point, not 2. Okay, so that means this x value gets mapped to only 1 y value, as opposed to this here gets mapped to 2 y values. So this one is a yes. Okay. All right. So that's how you figure out whether or not something represents a function. So we looked at it graphically, where you can use the vertical line test. And we looked at here by using the definition that every x value needs to get mapped to exactly 1 y value. Okay. Again, it doesn't matter if they go to the same y value. Where is that one? Are you guys dizzy yet? Okay. Okay. So here they can go to the same y value. It's okay. This is not a function because x3 didn't get anything. They all have to get something. Okay. Exactly one thing. Okay, so that is it. If you have any questions, again, make sure you email me, make sure you text me, and make sure you keep up with the homework, please. See you in part 2.